All right, let's dive in. Today, we're talking about a technology that was born because someone needed to handle data that was, and this is the actual word they used, humongous. That idea grew into MongoDB, a database that didn't just offer an alternative, but really became a pillar of the modern internet, and as we'll see, a huge player in the new era of AI.
But you gotta ask, why did we even need something new? What was so wrong with the old way of doing things? Well, as the internet took off, developers were in a race to build and change apps faster than ever before. The problem was, their databases were like concrete, rigid, structured, and incredibly slow to change. You can see where this is going. A massive collision was just waiting to happen.
So to really get why this was such a big deal, let's take a quick trip back in time. This first section is all about that old world of rigid tables. This was the world of SQL, where you had to know exactly what your data would look like, down to the last detail, and build a perfect little box for it before you could even write a single line of code. And this slide, this nails the fundamental difference. Think about it like this. A traditional SQL database is like a Lego kit for a specific car. You get a super strict instruction manual and exactly the pieces you need to build that car, and that's it. MongoDB, on the other hand, is just a giant, messy bin of Legos. It's meant for developers to grab what they need and build whatever they can dream up. That tension, that clash between the rigid car model and the creative open bin is what engineers call the object-relational impedance mismatch. And it was a huge headache that MongoDB was literally designed to solve. So solving that headache meant coming up with a completely new approach, one that put developers first. So what did that look like? Well, that brings us to section 2, a whole new way of thinking called the document model. To get this new model, all you really need is this little Rosetta Stone right here. In the new world, you can just forget about tables. Now we have collections. And forget about rows, we have documents. And those columns, they're now called fields. Now this isn't just swapping out words, it's a completely different philosophy. All the information that belongs together now lives together in a single document. So what exactly is a document? Well, under the hood, it's stored in a format called BSON. You can think of it as JSON's superpowered cousin. It's binary encoded, which makes it way faster and more efficient for the database to work with. But this structure also comes with a really important design choice. Every single document has a 16 megabyte size limit. And that's not a bug, it's a feature. It's a deliberate rule to keep the whole system blazing fast by making sure no single bloated document can slow everything down. Of course, just storing your data is only half the story. You have to be able to ask it questions, sometimes really complex ones. For that, MongoDB has something called the Aggregation Framework. It's like a powerful, multi-stage assembly line for your data. You can have a stage like $match, which works a lot like a where clause in SQL to filter things. Then you can pipe that into a $group stage, which is like group by, to organize the results. It's an incredibly powerful way to slice, dice, and reshape your data right inside the database itself. So we've got a flexible model and a powerful way to query it. Awesome. But that brings up a massive question. What happens when your app actually succeeds and becomes, humongous? That's what section 3 is all about, the engineering behind solving for infinite scale. The first part of the answer is something called a replica set. This is the secret sauce for keeping your app online, period. It's basically a group of servers that all keep perfect, identical copies of your data. Think of them as clones, constantly in sync with each other, ready to take over at a moment's notice. So what happens if your main server, the one they call the primary, suddenly goes offline? Well, the others don't even blink. They're all constantly checking on each other, sending these little heartbeats. The second those heartbeats stop, the other servers, the secondaries, instantly hold an election. Within a few seconds, they've picked a new primary to take over. And for your users, they notice absolutely nothing. Zero downtime. Okay, so replica sets keep the lights on, but that's a different problem from just having too much data for one single computer to handle. That's where sharding comes in. Imagine trying to cram every book in the world into one library. It would collapse. Sharding is like opening up thousands of neighborhood branches. You distribute the books and the people looking for them across many different locations. And this whole distributed system has 3 key parts that work together perfectly. You have the shards, which are those neighborhood library branches actually holding all the data. You have the config servers, which act as the master catalog, the system that knows exactly which book is in which branch. And then you have the query router, called Mongos, which is like the super smart librarian at the front desk who instantly directs every single request to the right place. But here's the thing, the story didn't end with just solving flexibility and scale. the tech world kept changing, and so did MongoDB. And that evolution is what this next section is all about, how a database grew into a full-blown AI-ready data platform. The engine driving all of this is MongoDB Atlas. It's a cloud service that basically handles all the boring, painful, but absolutely critical parts of running a database, what people in the industry call undifferentiated heavy lifting. I'm talking about things like backups, security updates, performance tuning, all the stuff that gives you a headache. Atlas automates it all, so developers can get back to doing what they're actually supposed to be doing, building cool stuff. And now, baked right into Atlas is a feature that's a total game changer for AI, vector search. This turns MongoDB into a database that doesn't just match words, it understands meaning. It allows for something called semantic search. So if you search for red fruit, it's smart enough to give you apple or strawberry, not because they contain the words, but because it understands the concept. So why is that so important? Well, it's the key to a technique called Retrieval Augmented Generation, or RAG. This is how you let a powerful AI model, like a large language model, securely use your company's private, up-to-the-second data. It means the AI can give answers that are accurate and relevant to your business because it's grounded in your actual information, not just random stuff it found on the internet. Okay, all of that sounds amazing in theory, right? But what does it actually mean in the real world? For our last section, let's move from the code to reality and look at a couple of case studies that show just how big of an impact this technology can have. So first up, let's look at Kiabi. They're a huge fashion retailer in Europe, and their old system was, to put it mildly, a train wreck. It was only online about 70% of the time. For a big e-commerce company, that's basically a death sentence. So they decided to rip everything out and rebuild their whole sales platform on MongoDB Atlas. And the results? Well, just look at this chart. They went from that fragile, barely working 70% uptime to a rock-solid 100% resilience. That meant during their most successful sales year in history, they had 0 downtime. All those sales they used to lose, gone. Just an incredible turnaround. Now for something completely different. Let's talk about the pharma giant Novo Nordisk. They had a huge bottleneck in their research, creating clinical study reports. It was this incredibly slow manual process. We're talking about 50 experts working for up to 12 weeks just to create a single report. It was a massive drag on innovation. So they used Atlas Vector Search to build a generative AI solution to tackle this problem. And the result is, honestly, it's just staggering. A highly complex, highly regulated process that used to take 12 weeks now takes 10 minutes. That's not just an improvement. That is a complete reinvention of how they do science. So we've seen this incredible journey, right? MongoDB started as a clever solution to handle humongous data, and it's evolved into the intelligent core for today's most advanced applications. And it really leaves us with one final powerful question to think about. What really becomes possible when your database can think?